What we're looking at today is inverse trig functions. And first off, when is the inverse of a function also a function? And that is when that function is one-to-one. And remember, that means it passes the vertical and the horizontal line test. Well, this right here is your parent function of sine. And what I want to do is I want to find the inverse of this. And I want the inverse to also be a function. So I am going to have to restrict the domain. So how can I do that? I'm going to have to restrict the domain. Now, I'm going to take a piece of this graph right here, and I'm going to start from here to here, from negative pi halves to positive pi halves. So this little piece of that graph is a function, and if I flip the x and y, it's also going to be, its inverse will also be a function. Here it is graphically. Here it is the original. So here my domain is negative pi halves to positive pi halves. I just took a portion of that graph. And of course, my range is still -1 to +1. So now if I take this graph and I flip this and change my x and y axis, this little piece, its inverse is 1-to-1. So here, of course, when you take the inverse, the domain and range change. So my domain is now -1 to +1. And the range here is negative pi halves to positive pi halves. So what you want to remember here is when we're taking the inverse of sine, if we're going from negative pi halves to positive pi halves, we're working in these two quadrants right here. We're working in quadrant 1 and we're working in quadrant 4. So here, anytime you're in quadrant 4, you're going to have to name your angle negatively. Because the way I think of it is, it can live in these two quadrants. These two quadrants are like forbidden quadrants. So if I'm in quadrant 4, I can't even travel through 2 and 3. I'd have to start in standard position and name it negatively. How does that work? So if you look right here, when you're saying I want the inverse of sine of 1/2. Now, there's two different ways to write this. You can write the inverse of sine inverse of 1/2, or that is the same thing as the arc sine of 1/2. Just a different way to write the same question. Now, I know with sine, it can only live in these two quadrants. So if I am looking for sine of 1/2, sine is y, it's positive right here. So the arc sine or inverse of sine of 1/2 is going to be pi6. You are saying, this question is asking, at what angle is sine 1/2? So where is sine 0? Well, sine is 0 right here at 0. So right here, it can only be in these two quadrants. Where is sine? Negative square root of 2 over 2. It's right here. And I can't name that like here 7 pi fourths because I've traveled through these two forbidden quadrants. So when I start here, because it's in quadrant 4, I'm going to have to name that negatively. So that's going to equal a negative pi fourths. And where is inverse sine -2? Well, that doesn't exist because sine can only live between positive and -1. All right, cosine. So here, cosine, I want to look at my cosine graph and take a piece of my graph that is going to make it a 1-to-1 function. So here, I am going to take this one from right here to right here. From 0 to pi is the part I'm going to use. And 0 to pi means it can only live from here to here. But I don't have to worry about naming anything negatively. From standard position, everything can be positive. So here, if I take this little piece of cosine right here, I'm having a domain of 0 to pi, and my range is -1 to +1. And if I take this graph and spin it around and change my x and y, my domain now is going to be -1 to +1, and my range is going to be 0 to pi. Now, remember, you can write it as arc cosine, or you can write this as cosine to the -1. So that means that what quadrants can the inverse cosine live in? Well, it can live in quadrants 1 and quadrant 2. So now if you look right here, again, I'm only looking at these two quadrants. So cosine is +1/2 right here, and that right there is pi-thirds. So I'm saying when cosine is 1/2, what is the measure of that angle? And that would be pi-thirds. Where is cosine 0? Well, that is right here, and that's going to be at pi-halves. Here it says, where is inverse cosine -√2/2? Well, that's right here, and the angle here would be a +3 pi-fourths. And where is arc inverse cosine 2? Doesn't exist because it oscillates between plus and -1. All right, now tangent. How could we make it so that the inverse is also a function? Well, we're going to have to restrict our domain again, and we're going to restrict it between those two asymptotes right there. So with tangent right here, our domain is -pi-halves to +pi-halves with parentheses, not brackets, because you have those asymptotes there. And the range here is -∞ to +∞. Well, now I'm going to look at this as my domain here is -∞ to +∞, and my range is -pi-halves to +pi-halves. So if I restrict my domain on the original, this is what the inverse would look like. I'm just switching those asymptotes from vertical asymptotes to horizontal asymptotes. So now, remember that tangent can only live in these two quadrants. These two quadrants are like our forbidden quadrants. We can't even travel through them. So here, tangent is the square root of 3, and that's right here at pi-thirds. So therefore, we're just going to call that a pi-thirds. So we're saying what angle is inverse tangent equal to the square root of 3. So now I want to know at what angle is tan inverse equal to 0? Well, right here, tangent is sine over cosine, 0/1 is 0. So at what angle is inverse tan equal to -√3/3? Well, that is right there. So we can't name that 11 pi-6. We're going to have to name that -pi-6 because you cannot travel through quadrants 2 and 3. And here, where is sine -1? Well, that's going to be right here, and it's at 7 pi-4. We can't name it 7 pi-4, so we're going to have to name this -pi-4. So now right here, this is some combinations or compositions of trig functions. Remember, you always want to work from the inside out. So first thing I'm going to do is look at sine of pi-6. So what is the value of sine of pi-6? Well, right here, sine of pi-6 is 1/2. Now I want to know what is the inverse, at what angle is inverse sine 1/2? Well, that's just pi-6. Now, here, this is not inverse. I want to find sine of 7 pi-6. Well, 7 pi-6 is right here, and sine would be -1/2. So now I want to know at what angle is the inverse sine -1/2. Now remember, sine can only live from here to here. So sine is -1/2 right here. I can't call it 11 pi-6. I have to name it negatively. So that would be a -11 negative pi 6. All right, so now here I want cosine of 7 pi 6. So cosine of 7 pi 6 is negative square root of 3 over 2. So I want to know at what angle is inverse sine negative square root of 3 over 2. And that's going to give me, and I have to name it negatively, so that's a negative pi thirds. And the sine of pi is 0. So at what angle is the inverse tan 0? And that's just 0. Here it's just some more composition of functions. Tangent of 7 pi fourths. Tangent of 7 pi fourths right here would be, 7 pi fourths is right here. That's negative 1. So at what angle is cosine inverse negative 1? And remember, cosine lives here to here. That would be pi. So now this is the sine inverse. So where is the inverse? At what angle is sine inverse negative square root of 3 over 2? Well, that is right here at 5 pi thirds. But I can't name it that. I'm going to have to name it negative pi thirds. So what is cosine now of negative pi thirds? And that is a positive 1/2. Now, on something like this, you're going to have to draw your reference triangle. So on this problem right here, first off, cosine, remember, can live in these two quadrants. So which one of these two would cosine be positive? So that's quadrant 1. So when I sketch this, I'm going to sketch a quadrant 1 angle. Theta is always with the origin and the x-axis. Cosine is adjacent over hypotenuse. Pythagorean theorem makes that a 4. So that's taken care of. So now I'm just going to read my triangle and say, okay, what is the sine of this triangle? Well, sine is opposite over hypotenuse, which is just 4/5. Right here, I want where the arctangent is 2. Well, tangent, arctangent, can live in these two quadrants. Which one of these quadrants is tangent positive? It's right there. So when I draw this, I am going to draw a quadrant 1 angle. Theta is with the origin and the x-axis. So tangent is adjacent, opposite over adjacent. Pythagorean theorem makes this the square root of 5. So what is the sine of this triangle? Sine is opposite over hypotenuse. So I've drawn my triangle, so sine is opposite over hypotenuse, and I'd rationalize, which would give me 2 square roots of 5 over 5. And then I have this one, cosine inverse is 13 over 14. Well, remember, cosine inverse can live in these two quadrants. Which one of them is cosine positive? It's right here. So I am going to draw my triangle as a quadrant 1 reference, and I know that cosine is adjacent over hypotenuse, so that is adjacent over hypotenuse. I'm going to use Pythagorean theorem, 14 squared minus 3 squared, and that is going to give me, I think it was the square root of 27. So here, this is going to give me the square root of 27, which is going to give me 3 root 3. So now what I want to do, I've drawn my triangle using the given pieces of information. So now what I need to do is find the cosecant of this triangle. Well, remember, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse. Well, cosecant means flip it. So that's going to be the hypotenuse over the opposite. And then I'm going to rationalize, which is going to give me 14 square root of 3 over 9, and that would be my answer.